Welcome everyone to this seminar that we are having on cloud architecture. It's part of everything meetup by India on the 18th of December. That's today. Let's just go through the contents that we're going to cover. We'll have an introduction to the Internet of Things, and followed by an introduction to the cloud, IoT architecture, IoT gateways, IoT sensor interfaces, IoT network interfaces, the cloud architecture, data acquisition, data storage and aggregation, data analytics, and user interfaces. So we begin with an introduction to the Internet of Things. So what exactly is the Internet of Things? So far, the Internet as we know it connects humans through computers and other devices like mobile phones, tablets, etc. So taking the concept of internet forward, we now it could be a refrigerator, it could be our television, and a host of other devices which we intend to get data from and eventually control these devices. So you could possibly have a situation where you have a microwave oven and you want to prepare a certain dish, or you have an oven, I'd say. So you want to prepare a certain dish. So it starts off with you having to set the temperature, the power, and you obviously have to put the dish into the oven. So here we have a situation where we have to manually set the parameters for temperature and power at the time. The next step would be where you have something like a setting, and you say, if I have to cook an item A, I press one button and it reads out data from its memory, which gives it the settings that we would have normally provided manually. So, for example, the data stored would include the temperature, the power, and the time required for preparing this dish. The next step would probably include a situation where we don't have the settings for a particular dish that we intend to prepare. So in this case, a smart machine would be able to access the internet to sources of information about the settings required to prepare this dish. So it will download the information into its memory and continue to cook or prepare the dish based on these settings. Now, taking it to the next step forward is the ingredients that would be required to cook this dish. So initially, going by the same method, we'll have to have a lookup of that would be required to cook. So again, the next step is we actually don't know what is the ingredients to cook the dish. So we have this smart oven which looks at the ingredients from the internet and tells you that these are the ingredients that would be required to prepare this dish. So we are done with two things. We have got the ingredients, we have got the settings for preparing this dish. Now the next thing comes to availability. So just like a smart oven, we have a smart stove. So if you require ingredient A, B, and C, the oven would go and find out if this ingredient is available in the stove. So if it's available, it lets you know that ingredients are available, settings are available, we can proceed with this dish. The next step further, we would have the store. So we have another smart device coming in here, which is the food store. So when the oven asks for a particular set of ingredients with a particular quantity, it looks up uh, whether it has it in store. If it doesn't have it in store, it proceeds to order the ingredients from the store that you have hooked up to. So that's in of what we can expect with the evolution of the Internet of Things. So again, we just come to a bit of definitions. So the Internet of Things is a scenario in which objects, animals, or people are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. IoT has evolved from the convergence of wireless technologies, micro electromechanical systems, and the internet. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built in sensors to alert the driver when tire pressure is low, or any other natural or man made object that can be assigned an IP address and provided with the ability to transfer data over a network. So this is basically fundamental to the Internet of Things. You need a device. You need a device that can be assigned an IP address, which will be the unique identifier for the device, and it has the ability to transfer data over a network. So far, the Internet of Things has been most closely associated with machine-to-machine communication in manufacturing and power, oil, and gas utilities. Or other, these are the places where they have been mostly put to use, unlike the example that we referred to, and which is still evolving. And we know we still don't have a smart oven that can order things for you, but we are getting there someday. Products built with M2M communication capabilities are often referred to as being smart. So we take the next part, which is the introduction to the cloud. So cloud, as we have known it, it has mostly been put into use or has evolved in terms of cloud computing. The cloud has so far been associated with computing, where you have huge resources which are available on the cloud. So you transfer data to the cloud, and you have vast resources of computing power on the cloud. So if you look at this, you have an application, a platform, and the associated infrastructure on the cloud. So you could have phones, laptops, servers, desktops, and tablets connected to the cloud to take advantage of the features that the cloud offers, which is it could be running an application, it could be utilizing a platform or the infrastructure. Similarly, you have a service provider in terms of you could have mobile service provider, or you could have a service provider offering power. So you have the service provider hooking up to his service network, and data from the network again being hosted on the cloud. So let's again come back to some definitions. Cloud computing is typically defined as a type of computing that relies on sharing computing resources rather than having local servers or personal devices to handle applications. In cloud computing, the word cloud, also phrased as is used as a metaphor for the internet. So the phrase cloud computing means a type of internet-based computing where different services such as servers, storage, and applications are delivered to an organization's computers and devices through the internet. So let's come to the IoT architecture. So let's consider a reference architecture for IoT. So at the root or fundamental to the Internet of Things are things which are also called devices. So you could have uh, a computing device like the Raspberry Pi, a car, a device emitting Wi-Fi, and it could also be your home. So a home with a number of devices capable of emitting data, which could be used for analyzing the condition of your house, the temperature, the humidity, and taking actions based on that. So once we have the devices in place, the next thing we need to have is a means to transfer data from these devices to the cloud, which is the most suitable place to process huge amounts of data that is acquired from these devices. So you have a network. So it could be a mobile network, it could be a wireless network, or any other kind of network which could be used for this purpose. That forms part of the physical layer. The next thing comes to the protocols associated with transfer of data from these devices to the cloud. So you have a host of protocols which we'll see later, which transfer this data. So here we have an example of MQTT and HTTP. So before we go into what happens on the cloud, we'll have a look at what we could do with the devices themselves. So we have something called a device manager, which will allow you to define the devices, establish relationships between these devices. So if, for example, like we said earlier, if you need a smart oven to talk to a grain store or your storehouse, so we need to let them know how to communicate with each other. The next thing we need to look at is identity and access management. One of the concerns with exposing all the devices that you have to the internet is obviously you have to control access to these devices. You have to ensure that access is available. At the same time, it is done securely. So we need to identify which devices are allowed access to our network, and we need to have some mechanism to ensure that only or the devices connect securely. So that is managed by identity and access management. Okay, now having completed the device side, now we come to what do we do with the data that we have collected from all these devices. So the first step, obviously, we need to store that data as is received. The next step would be to run aggregation. So we need to like know, so a typical data that we could get from a house is the current energy consumption. So that will give you the energy at this point of time. And what we need to do is we need to find out the total energy consumed over a period of time. So that is achieved by a process called aggregation. So we know at the end of the month what should our electricity bill be. So that is the aggregation. Come to what is called event processing. So for example, the data from your devices, say you have a temperature, a thermostat at home, one of the devices, and it is pushing data to the cloud, and you want to take certain actions based on the temperature setting. So if you have determined that if the temperature crosses 24 degrees, you have to turn on air conditioning in your house. If the temperature falls below 5 degrees, you turn on the heating system. So you have these algorithms set in the cloud, which will process these events and take action accordingly. The next thing is we would want to run analytics on the data that we have collected. So, for example, we would want to know what has been the trend of energy consumption in the house. So, we get an idea of how energy is being utilized in the house. So we need to know what action, this will give us an idea of what action we need to optimize use of electricity. So that's done using analytics. And finally, we need to view all this data. So we have a portal which will host, which acts as an interface for data that we have already stored, aggregated, and processed, and a handheld device or a computer which will allow us to see the status of our devices. This is usually managed through what is called a dashboard. A dashboard allows you to or dashboard gives you an overview of what is the state of your devices. If it's your house, it will show you parameters. It show you probably a layout of total energy consumption in different rooms in the house, which air conditioners are on, which air conditioners are off, the heating system, the cooling system if that is applicable. So if there's a security system, whether there has been an alarm on the security system, and things like that. And finally, we come to what is called API management. So an API is a concept where we share data between two platforms. So for example, we have a platform that implements all that we have done, but we don't have uh, a facility where we can send, say, an SMS on an event. So what we do is we hook up to another platform which offers this service. Now, platforms typically exchange data by what is called an API. So uh, the SMS facility or the SMS platform would have uh, a feature where we can send we can request for an SMS to be sent to a particular mobile number, and we can define the text that goes with the message. So I'll just make a call to this particular platform, pass on the data, and it will return data again, saying, informing me whether the process was executed the way we intended or not. So that gives you a complete reference for an IoT architecture. Okay, so now taking all these components, we could define an IoT platform uh, as having three essential parts. One is the things, of course. The second is the gateway, and third is the network and cloud. So let's begin with the IoT gateway. So just coming back to this, we'll just elaborate on the gateway. So things basically are capable of uh, transmitting data, or they collect data in some form and transmit it using low level protocols to a gateway. A gateway basically is the gateway to the internet. So it communicates using internet protocols and passes on the data to the cloud. And the cloud further processes the data as we have seen earlier. So now let's begin by understanding how we go about building a gateway, or what are the components of a gateway. Would have a board which is capable of handling data out by the things. It needs to have sufficient processing power to handle the data coming in from these devices, and it also needs to pass on the data using specific protocols to the cloud. So the heart of a cloud platform, open source boards like the Raspberry Pi, the BeagleBone Black, and the Intel Galileo, etc. These are usually Linux boards that run different flavors of Linux like Raspbian, on the Raspberry Pi, Angstrom, on the BeagleBone, etc. Interface with devices on the one, and the cloud platform. Now we come to the sensor interfaces. So we have a sensor like we've been seeing all along. We have, it could be a thermostat, it could be a humidity sensor, or the like. So a sensor is incomplete unless it is capable of transmitting that device using predefined protocols to the gateway. So in this case, as we have seen, we could use a wired interface or a wireless interface. A wired interface could be direct hardware connected to what are called physical inputs. So you have physical inputs, for example, on the Raspberry Pi, to which you would directly wire up these sensors. The other option is to use a serial interface, which allows multi-dropping of a serial interface to a number of devices. So eventually you could have two wires being multi-dropped connected to something like 25 to 30 devices. So if you go using the wired route using an RS485 interface, you could connect probably all the devices in one house. So it's one RS485 connecting all the devices that you have in a house. In an industrial environment, you will have multiple such interfaces to cater to the larger number of devices that need to be connected. Coming to the wireless network. So there are different protocols that could be used for building up a wireless network. In this particular case, we have considered an XB mesh network. So an XB allows you to create a wireless mesh network. Using a wireless mesh network allows an extended network which can run into a few hundreds of meters or more. So it could practically cover the entire house or even a small industrial facility. Unlike a Wi-Fi network, which is essentially a point-to-point network and therefore has limitations on the reach of the network. So now, replicating the case of what we did with the wired connection, in the case of a wireless network, you would have a Zigbee, that's called it's a radio, which would be connected to each of these devices. The devices are connected over the mesh network. So one XB per device forming a mesh network and connected to the Pi or any other Linux board, which will have the which will have another XB, which is network. So it's just repeated here. We have the example where devices could interface with the Raspberry Pi over RS485XB, and RS485 network allows a multi-dock serial wired network allowing a host of devices to connect. The XB creates a wireless mesh network allowing large number of wireless devices to connect. These are open source interfaces and allows creation of a large sensor network. We could also use the GPIO on the Raspberry Pi for physical inputs. Now we come to IoT network interfaces. Now, so far we've managed to get the data from the devices up to the gateway. The next task we have is to transmit this data from the gateway to the cloud. Here we can use the different options available. You could use a simple Wi-Fi dongle, or you could use the Ethernet. There's an Ethernet on this, or you could use a GPRS shield if you intend to use a 2G or a GPRS network. So you'll have options, you'll have a 3G shield or a 2G shield, which could be used accordingly. So the next interface we look at is the cloud interface. This is achieved using a simple Wi-Fi dongle or a GPRS shield. Interfaces over USB, and the GPRS shield uses the serial interface. Also available is the Ethernet port, which could be used for interface. Now we come to the cloud architecture. So now let's take a look at what a typical cloud architecture would look like. It all depends upon what kind of data you're handling and what is the eventual value that you intend to extract out of the data. So, for example, here again we come back to the devices. You've got automobiles, aeroplanes, and various other things. So, here they typically transfer data using low level protocols. So, we protocol translator, which will allow it to be transferred to a device service interface. So you have got some using the native protocols and things like that. So once it comes to a device service interface, the first thing you need to do is store that data. So you store that data. The next thing you need to do is you could run real-time analytics on it. You run real-time analytics on it, and then you save the raw data to a NoSQL kind of a database. That is how it's typically implemented. Once that is done, you need to run analytics, map reduce on it, and you next go to a business logic layer, which allows for applying logic to the data. So you could have the which could also include alarms, generating custom alarms out of the data that you have received and things like that. And that will again interface with real-time updates to give notifications. So you have push services which inform you using email. You could update it using a message broker. So if you have devices or rather clients that are listening for events generated by your system, you will push it to a broker, and there'll be clients subscribed to that which will take on from that data. Same thing with MQTT. And on the view side, you have a web application server, and you have an interface that allows you to see uh, your data in different forms. The raw data, the aggregated data, the data after you have run analytics on it. So you can see historic data, you can analyze your data for trends and things like that. So eventually you will have an opportunity to see all Okay, so now we could look at another reference architecture. So this is basically sourced from Microsoft. So here again, the usual, we have the applications, the devices, the sensors, and of course, web and social data too. You get data from Twitter, you get from Facebook, and all these sources. Sorry. So you have field gateways that are basically going to push this data to the cloud. And in the case of devices specifically, you need gateways, as we have seen earlier, which will take this data from the devices, do a protocol conversion, and push the data to the cloud network. So on the cloud, you could handle the data in different ways. So typically, as we've seen here, you have a message we have Apache Kafka as a message broker here. So it allows you to queue your messages. So there is no issues with loss of data, because it allows queuing all the messages that come in, so you can handle it at your own speed, rather than being pushed with data which you're not capable of handling. So the first part of a typical cloud architecture would include a message broker. Once the data has come in, you can handle it differently. In this particular case, we have we use Apache Storm, which is used for stream processing. So basically what stream processing would imply is we want to extract value out of the data that we are receiving. So for example, just consider the case of a Twitter feed. So a Twitter feed is something like 140 characters. Now, you could extract a lot of information out of this feed. For example, you want to know whether there are any hashtags in the tweet, are there any at mentions in the tweet, and so on and so forth. So you analyze a Twitter feed or a tweet for information using Apache Storm. So Storm extracts out uh, the hashtags, the at mentions, and other information that you want to extract out of a tweet. So you've done two things. One thing is you've got the message in the which is the tweet. You've extracted out useful information using Storm, and now you need to push this data into storage. You got the data, you extracted out useful information from it, and now you push it into long-term storage, which they use Azure HBase or Apache HBase. Now, having done that, the last requirement of this platform is that you need to present this data to a web client. You need to allow for search and query, run data analytics on it, and allow devices to take action. So, for example, I look up, I log into Twitter, I put in a hashtag, I search for a hashtag, and it lists out all the tweets associated with the hashtag. So that part of it is actually being handled by Storm. So this is how we take in data from a device, sensors, or the web. We process it based on our end requirements. Again, we run analytics on it. We need to find out, how many times a tweet has been retweeted, what is how we arrive at a trending topic in Twitter, and things like that. Okay, so we come to a more industrial kind of cloud architecture. Here we have devices which includes a speedometer, an odometer, or an odometer. You have a stethoscope, mobile devices, a truck with all the sensors embedded in it, and you could use any kind of connectivity. It could be Wi-Fi, it could be a 3G network or whatever, and then we push the data to the cloud. So cloud here, it has support for REST API. It could support MQTT, COAP protocol, or it could be any custom protocol. Now, once the data is has come in, we apply a rules engine. So rules engine, as we have seen earlier, very similar to Apache Storm. So we assign criteria to it, that we need to generate an alarm, generate a hash, or generate a list of hashtags or whatever. So that's what goes into a rules engine. We allow for storage, and based on these rules, if the events come in, if an event comes in, what action has to be taken. So we push data, and we also pull data from the application. Now we come to the next step. We go into a little bit more detail about cloud data acquisition. So without going into specifics about how we go into the data acquisition, which will be covered in subsequent webinars that we're going to have, we'll just take a nice little package which does most of it for us. So we've got Ponte, which is an aggregation of a number of sub servers, sub packages, which allows for implementation of the cloud platform that we intend. So here we have the Ponte includes an HTTP server, an MQTT server, and a COAP server. It's just built in, so you could use it as it is. It allows for persistence using, you can push your data to MongoDB, to Redis, or LevelDB. It allows for PubSub, so you can push to a RabbitMQ broker, you could push to MongoDB, you could push using MQTT and Redis. It also has a provision for protocol conversion in the sense that you could push data using HTTP and subscribe to data using HTTP or COAP. So it's just a brief note. It's developed by this person called Matthew Colina. It supports three of the most widely used protocols for gateway interfaces, namely HTTP, MQTT, and COAP. It supports multiple databases. As we have seen, it's got an inbuilt PubSub mechanism for publishing and subscribing, and so on. So the next thing we come to is data analytics. So data analytics, I just give you a an overview, so which we would be again covering in subsequent webinars that we will be hosting. Data analytics, we have a host of tools. Again, we use them in different combinations. So Hadoop provides you a distributed data store in that sense. So you with big data and data analytics, you will be coming across a lot of distributed things because there's so much amount of data, you cannot handle it in isolation. You need to distribute the data to different points and from where it can be handled. So you've got Hadoop, which looks into distributed file storage. Spark basically does distributed computing. You've got Kafka, which is a distributed message broker, as we have seen earlier about message brokers getting the client subscribing to that data. And Storm, we have again seen Apache Storm earlier, which is basically going to allow you to process streaming data. Then Mahout, Hive, and R basically into machine learning and data analytics. And MongoDB is, of course, a NoSQL data store. And finally, we come to user interfaces. So user interfaces, we have got a lot of options available for building the user interfaces. You could use HTML plus JavaScript plus jQuery and the like, the conventional way, or you could add on some MVC frameworks like Backbone or something like that. Or the current trend is basically using AngularJS, Node.js, and MongoDB. So they are they use acronym MEAN for that. It's called the MEAN stack for MongoDB, Express, AngularJS, and Node.js. We'll be again covering the cloud view in one of our subsequent webinars. So just to give you an overview of how we implement the view on a cloud platform. So that's it. So this is what we had to talk about